Today's vodcast, V52, starts on slide 82 and goes through slide 100. The topic today is word problems with probability. Let's take a look at an example. Our first example has to do with soccer, and Erica scoring goals in soccer. Her coach says that she scored 19% of her attempts last season, and this year she says it should be the same. And Erica says last year she shot 1,100 goals, so they're going to use experimental probability to predict how many goals she's going to score this year. So first we have to dissect this problem a little bit because the information's not clear. They tell us that she scored 19% of her attempts, but we want that as a fraction. So we're going to take what we know about percents and make it into a fraction. So for probability, we have the favorable outcomes that we want over the total. For 19%, that's 19 shots made out of 100, because 19 over 100 is 19% as a fraction. So this explains it in another way. Experimental probability is the number of times the outcome happened over the number of times that the experiment was repeated. So in this case, it's number of goals over number of attempts. And we're going to set up a proportion in order to solve this. So in this case, we're going to use some estimation. And a lot of this information is not in your slides, so please write it down. We're going to estimate. So Erica made 19% of her shots on goal. About what percent is a good estimate for that? Well, 19 is very close to 20, so we're going to use 20% instead of 19 just to estimate. And she took 1,100 shots on goal, and that's about an estimate of 1,000. So we're going to estimate that she had about 1,000 attempts on goal. So using this estimation, we're going to solve. We want 20% of 1,000. Or we're setting up a proportion to represent what happened. So using favorable over total, 20% we already said was 20 goals out of 100 attempts. So 20 goals out of 100 attempts is some amount of goals over 1,000. The goals are what's favorable, and the denominator is the total. So from here, if we cross multiply, we get 100x equals 20,000. And if we divide both sides by 100, we get x equals 200. So Erica figures she made about 200 of her shots on goal. And again, we estimated, so this is just an estimate. And please write this down. It's not already in your slides. So now we're going to do the problem for real using the actual numbers in the exact same way we just did. So we're still using favorable over total. And we're using 19% and 1,100 instead. So our favorable, our amount of goals is 19 out of 100, that's our percent, over, we're not sure, over our total amount of goals, 1,100. When we cross multiply, we get 100x equals 20,900, and x equals 209 goals, which is very close to our estimate. Here's another example, but with tulips this time. So Lexi planted 12 tulips last year, but 10 of them bloomed. This year she's going to plant 60 tulips, and we're going to predict how many bulbs will bloom. So again, using favorable over total, we have the number that bloomed over the total, and over here we don't know how many bloomed yet, over our new total. So we can solve this proportion the exact same way we've been doing by cross multiplying, or if you want, you can solve it by equivalent fractions, and if you remember, that just means that you try to find something that you can multiply the first fraction by to get to the second one. So in this case, 12 times 5 gives us 60, so if we multiply the top by 5 as well, that gives us 50, and 50 is our number that we can expect to bloom this year out of 60. So again, this is one way to solve it. You can also solve it using cross multiplication, and we have an example of that in the last problem. Our next example shows us using cross products like we're used to. So we attempted 53 free throws today and made 32 of them. We want to predict how many free throws we'll make if we attempt 75. So we want the favorable, which is making a free throw, out of the total, which is the attempts. So today we had 32 out of 50, and then we want to predict for tomorrow. We don't know how many we're going to make, but we are going to make 75 attempts. So we're going to solve using cross products. 50 times x is 50x. 32 times 75 is 2400, and if we divide by 50 on both sides, we get 58 free throws as a prediction for tomorrow. This slide gives us a chart about the number of goals that we've made out of the number of attempts. The question's just asking you to find the experimental probability. So I've done the first two for you, and you're going to do the next two on your own. So the favorable is the goals, the total is the attempts. 30 over 100 is the experimental probability, which reduces to 3/10. For the second one, 600 over 1000 is the experimental probability, and that reduces to 3/5. Please try the other two on your own. Let's take a look at our first responder question. Tom was at bat 50 times total and hit the ball 10 times. We're looking for the experimental probability for hitting the ball. We're looking for the favorable, which is the number of times he hit the ball, out of 50 times total. So 10 over 50 reduces to 1/5, and that is our experimental probability. This next question asks us to use the information from the last question. So Tom's experimental probability was 1 over 5 because he was at bat 50 times and hit the ball 10 times. Now we want to use that to estimate how many times Tom hit the ball if he was at bat 250 times. So since 250 is the total, that goes on the bottom, and we're solving for x. When we cross multiply, we get 5x equals 250, or x equals 50 times that he hit the ball. This next question asks us about a deck of cards, so you need to understand how the cards work in a deck. We want the theoretical probability of selecting a jack from deck of cards. So our favorable over total here becomes jack over total. So we want to know how many jacks we can pick from a deck of cards. Well, there are 4 jacks in a deck of cards, one of each suit. So that's 4 chances over the total number of cards, which is 52. That reduces to 1/3, which is our final answer here. 1/13. Please try the next 2 slides, slides 93 and 94, on your own. Let's take a look at this problem on slide 95. We have books laid on a desk, and I've written them out here for you. 2 are English, 3 are math, 1 is French, and 4 are social studies. Teresa selects an English book, and Isabel selects a social studies book, and they go off. If Truman then selects a book at random, what is the probability that he selects an English book? So let's see what happened again. Teresa selected an English book, and Isabel selected a social studies book, and then they left. So those books are gone now. 1 English and 1 social studies. And then we're going to do favorable over total again. And in this case, what he wants, or what we want to know, is for an English book. And there's only 1 English book left. Out of a total of 1, 2, 3, 4, 5, 6, 7, 8 books total, that gives us a probability of 1/8. We are going to skip the next 2 slides. That's slide 96 and 97. Slide 98 has a lot of writing, so I'm going to highlight some information for you, and we're going to go through this really slowly. Lindsay is surveying people at a movie theater, and she's seeing who's going to buy movie tickets and popcorn. Her data is listed below, and she says that from the past data, the probability that a person who is selected at random that buys a movie ticket will also buy popcorn, that probability is 0.6. So she's testing it. She's doing an experiment to test it. And she's estimating that exactly 2 in a group of 3, because 2 out of 3 is 0.6, repeating, at a movie theater will buy both a movie ticket and popcorn. And she used a number generator that generates random numbers to show her data to us. So here's how the generator works. Any number from 1 through 6 is a person who buys ticket and popcorn. The numbers 7 through 9 and also 0 is a person who buys only a movie ticket. So let's take a look at this chart over here. Each one of these 3-digit numbers represents the 3 people. So using this information, we'll look at this. The first person is a number 2, so they bought a movie ticket and popcorn. 6 also bought movie ticket and popcorn, and so did this 6. So out of these 3 people, all 3 of them bought a movie ticket and popcorn. And that's not what we're looking for. We're looking for exactly 2 people out of 3. So let's take a look at another example. 139. This person is a 1, so they bought a movie ticket and popcorn. The 3 also bought a movie ticket and popcorn, but the 9 did not. So this is a person that we're looking for. 2 out of the 3 in the group bought movie tickets and popcorn. So let's use that information to try an example. And I brought the information over. So remember, numbers 1 through 6, the people bought a movie ticket and popcorn. 7 through 9 and the number 0 just bought a movie ticket. So our question here is one result was a 100. So the first person was a 1, the second person was a 0, and the third person was a 0. So which one does this represent? Well, let's look up here. The 1 bought a movie ticket and popcorn. The 2 zeros just bought a movie ticket. So we know that this represents 2 people who just bought a movie ticket and 1 person that bought a movie ticket and popcorn. So let's see what choice gives us that information. A says no one in the group who bought movie tickets also bought popcorn. Well, that's not true because we know that the number 1 bought movie tickets and popcorn. B, exactly 1 person in a group of 3 randomly chosen people who buys movie tickets also buys popcorn. This one is true because 1 was the only person who bought movie tickets and popcorn. So B works, but let's check the other 2 just in case. Exactly 2 people in a group of 3 randomly chosen who bought movie tickets also bought popcorn. That's not true because these 2 people just bought movie tickets. And D, all 3 people in the group of 3 who bought movie tickets also bought popcorn. This is also false because only 1 person bought both. So in this case, B is our correct answer. We're going to skip the last question, slide 100, and this is the end of the podcast.